We are going to start with question number 11 today. Question number 11. Look at the question. It says, show that the relation R in the set R, the real numbers, defined by R is equal to set of all ordered pair A comma B such that A is lesser than or equal to B square. So we will say that A is related to B if A is lesser than or equal to B square. For example, I will say that 5 is related to B if the first number 5 is lesser than or equal to 4 square, the second number square. So is 5 related to 4? 5 lesser than or equal to 4 square. 5 is smaller than 16, 4 square. Therefore 5 is related to 4. So that's the meaning of the relation. The first number should be always smaller than or equal to square of the second number. Now, but we need to prove that it is neither reflexive nor symmetric nor transitive. So, if we want to ever prove that something is not true, we give counterexamples. What's the meaning of reflexive? Reflexive means every number of the given set should be related to itself. Like 1 should be related to 1, 2 should be related to 2, 3 should be related to 3. Actually, if I take 3, 3 is actually related to 3. Because 3 is, according to this relation, 3 is smaller than 3 square. 3 is lesser than 9. 3 is smaller than 3 square. So first number is 3, the second number is 3. 3 is lesser than 3 square. So 3 comma 3 actually belongs to R. But I need to prove that it is not reflexive, which means there is at least one number which is not related to itself. And we can see that any number between 0 and 1 is actually in that category. I'm picking up half. Half comma half does not belong to R. But why I need to prove? So I need to give the reason, I need to justify why half is not related to half. If half is related to half, then the first number half should be lesser than 1 by 2 squared. But no, 1 by 2 is actually greater than 1 by 2 square. 1 by 2 is bigger than 1 by 4. And therefore, half comma half does not belong to R. And since half comma half, A comma A does not belong to R, it is not reflexive. R is not reflexive. Now I need to prove that it is not symmetric. And what is symmetric? Symmetric, when you say if A goes to B, then the other way around B should go to A. If 1 is related to 3, then 3 should be related to 1. So that's the meaning of symmetry. But I'm going to pick up a pair to show that it is actually not symmetric, a counter example. So I'm saying 1 comma 2 belongs to R. 1 is related to 2, but justify why, as 1 is smaller than 2 square. But the other way around, 2 comma 1 does not belong to R, because the first number A happens to be bigger than second number square. 2 is greater than 1 square. We are always supposed to get the first number as smaller than second number square, but I get the first number as bigger than second number square. 2 is greater than 1 square. Therefore, R is not symmetric. So we got a counterexample. 1 goes to 2, but the other way around, 2 does not go to 1. Therefore, R is not symmetric. And transitivity is A is related to B, the same B is related to a C. Then if I am able to show that A is directly related to C, then we say it is transitive. But your question is saying it's not transitive. So if A goes to B and then B goes to C, I should be able to prove that A won't directly go to C. So we're going to pick up 3 numbers, a triplet. 5, 3, 2 is what I'm going to use. 3 numbers, A, B, C, 5, 3, 2. And I say 5 comma 3 belongs to R. 5 is related to 3 and 3 is related to 2. We justify this way. 5 is smaller than 3 square, that's why 5 is related to 3. 3 is smaller than 2 square, 4. 3 is smaller than 4, therefore 3 is related to 2. But 5 is not directly related to 2. 5 goes to 3 and 3 goes to 2, but 5 does not go to 2 directly. 5 comma 3 does not belong to R because 5 happens to be bigger than 2 square. A is bigger than 2 square. Actual relation is A should be smaller than B square, but I get it as 5 greater than 2 square, and therefore R is not transitive. So the triplet you need to remember is 5, 3, 2, which will smoothly work there. We have an exactly similar question, but the relation is slightly differently defined here. Instead of a lesser than or equal to b square, now I have a lesser than or equal to b cubed. And I'm asked to check if it is reflexive, symmetric, or transitive. You should remember that it is actually not reflexive, not symmetric, and not transitive. That's why we pick up counterexamples. Half comma half does not belong to R. For it to be reflexive, every A should be related to itself. If I say 5, 5 should be related to 5. And it is actually. 5 is smaller than 125, 5 cubed. 7 is related to 7. 7 is lesser than 7 cubed according to the relation. But what I am looking for is a number which is not related to itself. That's where numbers between 0 and 1 would work for you. Half, comma half does not belong to R. Half is not related to half. Why? Because half is greater than half cubed, 1 by 8. Half is bigger than 1 by 8. So you got a pair here, half comma half does not belong to R. A number which is not related to itself. So every number is not related to itself. So it is not reflexive. Now we need to prove that it is not symmetric. So we know that 1 is related to 2 because 1 is smaller than 2 cubed. Now, does it go the other way around? So we are going to say, but 2 comma 1 does not belong to R. But justify, as 2 is greater than 1 cubed. 2 is greater than 1. I'm supposed to get 2 as smaller than 1. So 1 comma 2 belongs to R, but 2 comma 1 does not belong to R. And therefore R is not symmetric. Now for transitivity, here we use the triplet 10, 3, 2. Look at that, 10, 3, 2. Earlier we used 5, 3, 2. Now we use 10, 3, 2. So we'll make two pairs. 10, comma 3 belongs to R. A goes to B. And 3, comma 2 belongs to R. B goes to C. Now I'm going to check if A directly goes to 2. A directly goes to C. First justify these two. 10 goes to 3 because 10 is smaller than 3 cubed, and 3 goes to 2 because 3 is smaller than 2 cubed, which is 8. But 10 comma 3 does not belong to R, as 10 is greater than 2 cubed. So A goes to B, 10 goes to 3, and then B goes to 3, which is 3 goes to 2. So 10 goes to 3 and 3 goes to 2, but 10 does not directly go to 2. And therefore R is not transitive, and therefore it is not. No, okay, so we proved that it is not reflexive, not symmetric, and not transitive. We'll continue with the remaining questions in the next video.